Good morning everyone. Welcome back to my channel. Today I am going to discuss about motion in a plane part 3. Okay, today topic is resolution of a vector. What is resolution? Resolution means a vector is the process of obtaining the component vectors which when combined this line meaning is here. Let us consider, we can take one origin. Okay, this origin resolved into two components along x-axis, along y-axis, x component, y component. Here x component means along x-axis make an angle theta, that is cos theta. Y-axis make an angle sin theta. Here these two components along x-axis, along y-axis, these two components combined according to the law of vector addition produce the given resultant vector. Here now law of vector addition. Here x component is x, y component is y. This resultant vector is r bar. This resultant vector is small r bar. Here this x component and y component making an angle theta. Here we can draw a parallel rays q to r and p to r. We will draw a normal. Okay. Let us consider this is rectangle. This is OP is x. OP is x. And same thing QR is also x. OQ is y. In same thing PR is also y. Okay, here consider a vector r bar in the xy plane and it makes an angle theta with the x-axis as shown in figure. I bar and j bar are the unit vectors. I cap, j cap are unit vectors along x-axis, y-axis respectively. I cap, j cap is unit vectors. What is unit vector? Here it having same magnitude. Magnitude is 1. From the point R, drawn RP and RQ perpendicular to x-axis and y-axis respectively. From the parallelogram law of vector addition, OR bar is equal to OP bar plus OQ bar. Okay. As shown in figure. If OP is x bar, OP is x. Okay. Here OP is x, OQ is y. Okay. OP is equal to x, OQ is equal to y. Then OP bar is equal to x I cap. OQ bar is equal to y j cap. I cap and j cap are unit vectors along x-axis, along y-axis respectively. From equation 1, what equation 1? Here OR bar. OR bar is equal to R bar as shown in figure. OR bar is equal to R bar. OP bar is equal to X bar. OQ bar is equal to Y bar. Okay. Here R bar is equal to X I cap plus Y j cap. Here OP is equal to X, OQ is equal to Y. Along vector OP bar is equal to X I cap, OQ bar is equal to Y j cap. Okay. From triangle OPR as shown in figure, from triangle OPR, cos theta is equal to, what is the formula for cos theta? Adjacent side by hypotenuse. Adjacent side by hypotenuse. Adjacent side is OP bar. Hypotenuse is OR bar. Okay. Here cos theta is equal to adjacent side by hypotenuse Adjacent side is OP, hypotenuse is OR. OP is X, OR is R. That's why X is equal to R cos theta. In same thing, sin theta. From triangle OPR, sin theta is equal to, what is the formula for sin theta? Opposite side by hypotenuse. Opposite side is PR. Hypotenuse is OR. That's why PR is equal to Y, OR is equal to R. Y is equal to R sin theta. From 3 and 4, from equation 3 and 4, what we get? Tan theta. Tan theta is equal to, what is the formula? Sin theta by cos theta. Here sin theta is equal to Y by R. Cos theta is equal to X by R. Substitute this one, all those things. R get cancelled. What we get? Finally we get Y by X. Tan theta is equal to Y by X. This is direction. This is the direction of the rectangular component. The equation 3 and 4 gives the magnitude of the rectangular component vector. 3 and 4 gives the magnitude of the vector. Equation 5 is direction of the vector. From equation 2, what we get from equation 2 is, from equation 2, R bar is equal to X I cap plus Y j cap. Here R bar is equal to X I cap Y j cap. That's why substitute this one. R bar is equal to X I cap means R cos theta. Y j cap means R sin theta j cap. Okay. From right angle triangle, what according to Pythagoras theorem, what is the statement of Pythagoras theorem? Sides hypotenuse square is equal to side square plus side square. Hypotenuse square means OR square. Hypotenuse square from triangle OPQ. Okay, here hypotenuse is OR square is equal to side square plus side square. That means OP square plus PR square. Okay, here OR is equal to, finally OR is equal to what we get? Root of OP square plus PR square. OR is R smaller is equal to OP is X, PR is Y. Finally we get R is equal to root of X square plus Y square. This equation gives the magnitude of the vector in terms of its rectangular component in 3-dimensional space. For example, in 3-dimensional space, let us consider vector A is equal to AX I cap, AY j cap, AZ k cap. That means here that vector A is resolved into 3 components. Along x-axis AX component, along y-axis AY component, along z-axis AZ component. Okay, in 3-dimensional space. A is equal to AX I cap, AY j cap plus AZ k cap. In this case, that magnitude is A is equal to root of AX square plus AY square plus AZ square. Here in 2-dimension space, what is the formula? R is equal to root of X square plus Y square. In case of 3-dimension, A is equal to root of AX square plus AY square plus AZ square. Okay, here in this case magnitude, we can discuss about magnitude. Vector A in the xy plane, that magnitude is root of AX square plus AY square. Vector A in the YZ plane, root of AY square plus AZ square. Vector A in the ZX plane, ZX plane is root of AX square plus AZ square. In this case, the direction of the vector A component is theta is equal to tan inverse AY by AX. This is the rectangular components of the given vector. According to this problem, according to this topic, that is resolving power of a vector. According to this problem, small problem is there. A bar is equal to 3I bar minus J bar minus 4K bar. B bar is equal to minus 2I bar plus 4J bar minus 3K bar. And C bar is equal to I bar plus 2J bar minus K bar. Then find first one is A bar plus B bar plus C bar. Second one is A modulus of A bar plus B bar plus C bar. Third one is the direction cosines of the vector A bar plus B bar plus C bar. Okay, now here we can calculate the magnitude of the along given vector and the direction of the given vector. First we can calculate A bar plus B bar plus C bar. Here A bar is 3I bar minus J bar minus 4K bar plus B bar is minus 2I bar. Minus 2I bar plus 4J bar minus 3K bar plus C bar is I bar plus 2J bar minus K bar. Here 3 minus 2 plus 1 I bar plus minus 1 plus 4 plus 2 J bar plus minus 4 minus 3 minus 1 K bar. What we get is equal to 3 minus 2 plus 1, 4 minus 2, 2I bar plus 4 plus 2, 6, 6 minus 1, 5J bar minus 4 minus 3 minus 1. Totally minus 8 K bar. This is A bar plus B bar plus C bar. After that, second one, modulus of A bar plus B bar plus C bar is equal to what is the formula of modulus? Any vector is equal to root of x component plus root of x component whole square plus y component whole square plus z component whole square. That's why root of here a square plus b square plus c square. Here resultant vector is 2. 2 whole square plus 5 whole square plus minus 8 whole square. 2 square means 4. 5 square means 25. Minus 8 square is plus 64. Minus into minus plus. That's why here plus. We keep plus. Is equal to resultant vector is root of 93. Okay, next the direction of the vector. Cos alpha is equal to ax by root of ax square plus ay square plus jz square. This is along x component. Y component is cos beta is equal to ay by root of ax square plus ay square plus az square. Cos gamma, that means z component is az by root of ax square plus ay square plus az square. This formula is very important for MSET. Okay. Next, cos alpha is equal to ax. Ax is this one. 2 by root of 93 is equal to 2 by root 93. Cos beta is equal to, here y component is plus 5. That's why 5 by root 93. Cos gamma is equal to az by root of ax square plus ay square plus az square. Az is minus 8. Minus 8 by resultant vector root to 93. This is the direction cosines of the vector A bar plus B bar plus C bar. This is very important problem for MSET. Okay children, this class is wind up.